Okay, so pretty much everyone has heard of Bitcoin, right? But what about this second biggest crypto out there, Ethereum? Well, it's playing a totally different ballgame. While Bitcoin is all about changing money, Ethereum has this much bigger goal. It wants to change the internet itself. You see, Bitcoin was this revolutionary first step. It proved we could have digital money without needing a bank in the middle. But that breakthrough opens up a really fascinating question. If we can decentralize money, what else can we decentralize? What other parts of our digital lives, all run by these big middlemen, could be completely transformed by the same idea?
So here's our game plan for this explainer. First, we'll touch on the foundation that Bitcoin built. Then we'll look at why centralization is a problem that Ethereum is trying to solve. After that, we'll get into what this whole world computer idea is, how its engine, smart contracts, actually works, and we'll even dive into a crazy real-world crisis that put Ethereum's whole philosophy to the test.
All right, so to really get what makes Ethereum so unique, we have to start at the beginning. We got to go back to the breakthrough that really made all of this possible, Bitcoin. Think about it. Before Bitcoin, any kind of digital payment, it always needed a middleman. A bank, PayPal, someone you had to trust. Bitcoin flipped that on its head. It created a system where a whole network of computers validates everything, which means no single person or company can control it or shut it down. I love this analogy because it just hits the nail on the head. Bitcoin is just one use of the technology, kind of like how email is just one thing you do on the internet. The real game changer, the actual invention, is the blockchain underneath it all. That's the platform, like the internet itself, that you can build almost anything on top of. And that idea right there, that blockchain can be a platform for way more than just money, that brings us to the core problem Ethereum was created to fix. Because the problem with centralization isn't just about banks, it's about our entire digital lives. I mean, really think about it. Almost every single thing you do online, posting a photo, ordering a car, streaming a show, it all goes through some company's servers. They control the platform, they control your data, and they make all the rules. So what if we could build a new internet where we connect directly with each other with no one in the middle? It's kind of wild because the internet feels so huge and open, but when you boil it down, a tiny handful of giants really run the show. These companies are the gatekeepers. They are the centralized powers of the web we use every single day. And this is where Ethereum finally steps onto the stage. It was proposed way back in late 2013 as a direct answer to this problem. It was a new way to use blockchain to decentralize not just money, but, well, pretty much anything you can think of. And here is the number one thing to understand. Ethereum isn't really a currency. It's a platform. The best way to think of it is like a single, giant, global computer that no one owns and no one operates. Anyone in the world can write code and deploy applications on it. We call them Dapps, and those apps are guaranteed to run exactly as they're programmed forever. No censorship, no one can shut them down. Let's put them side by side. Bitcoin's code is intentionally simple. It's like a calculator, built to do one thing and do it incredibly well: handle money. Ethereum, on the other hand, it's more like a whole workshop. It's a do-it-yourself platform with a flexible programming language called Solidity, which means developers can build pretty much whatever they can dream up. Okay, but a world computer doesn't run for free, right? It takes a ton of electricity and computing power. And that's where Ether, or ETH, comes in. You can think of it as the fuel for the network. It's what developers use to pay for their apps to run on this world computer, and it's what pays all the people who help keep the network secure. So we've got this world computer, and we have the fuel for it. But how does it actually run anything? Well, the answer is this really powerful idea at the heart of Ethereum called smart contracts. Now, don't let the name fool you. A smart contract is just a program. It's basically a bunch of if this, then that rules written in code. But here's the magic. Instead of running on one company's server, it runs on the entire Ethereum network. That means it can't be changed, anyone can see it, and it runs all by itself. It's like a robotic lawyer and banker all rolled into one. So that still sounds a little abstract, I know. Let's use an analogy. Imagine a rental agreement is a smart contract. So if the tenant pays their rent in Ether directly to the contract, then the contract automatically sends a signal to unlock their apartment's smart lock. No landlord, no bank, no chasing down payments, just code. Now, that automation sounds pretty great, but there's a huge catch. Real-world contracts have a wiggle room. We call it the spirit of the law. A judge can look at the context. A smart contract can't. It is completely rigid. It follows the letter of the law, the exact code, no matter what. And once it's out there on the network, it can never be changed. And that rigid, unchangeable nature of smart contracts, well, it wasn't long before it ran headfirst into a massive real-world test, one that would shake the entire Ethereum community and force it to question its own core beliefs. See, from day one, Ethereum had this powerful motto: code is law. It meant exactly what it sounds like. The code of a smart contract was the absolute final authority. What it said goes. Period. No person, no court, nobody could overrule it. It was this pure mathematical vision. Then came something called the DAO. It was this new, radical type of investment fund built entirely on Ethereum. And it was a huge success. It raised an incredible $150 million worth of Ether. But there was a tiny flaw, a loophole in its smart contract code, and you guessed it, someone found it. And this is where things get really fascinating and really messy. The person who drained all that money, were they a hacker, a thief, or were they just cleverly using the rules that were literally written into the contract? I mean, if code is law, then technically they hadn't broken any rules at all. They just executed the contract as it was written. The Ethereum community was faced with an impossible choice: stick to your philosophy and let $150 million disappear, or step in and break your own rules. In the end, the majority voted to intervene. They basically hit an undo button on the whole blockchain to give the money back. But a small, passionate group said no way. They argued that breaks the entire point of an unchangeable ledger. So they stuck with the original chain, and to this day, it's known as Ethereum Classic. Wow. So that whole event was a huge lesson for everyone. It proved that building this decentralized future, it's messy, it's complicated. And even now, years later, Ethereum still faces some massive challenges on its quest to become that world computer it wants to be. And the biggest challenge by a long shot is just pure speed and scale. Right now, Ethereum can only process about 15 transactions a second. 15? For perspective, Visa processes something like 24,000 every second. If you're going to be a global computer, you have to be way, way faster. Now, there are big upgrades in the works that aim for an incredible 100,000 per second, but we're not there yet. So all of this leaves us with the big final question. The vision is absolutely incredible, right? A truly open global internet where we are in control, not giant corporations. But the technical problems are huge. And the philosophical ones, like we saw with the DAO, are just as tough. Can it actually be built? Honestly, no one knows for sure. But the quest to build it is, without a doubt, one of the most exciting experiments happening in the world today.